Okay, so now we're going to look at equations that are quadratic in form. So here we're going to be able to factor, but we're going to have to do some extra steps. So we're going to use substitution to make each of our equations look like a quadratic. Okay. So I gave you a table from your book that kind of shows you how the substitution process works. So if we look at this first row, we have x to the fourth minus 10x squared plus 9 equals 0. Or using our power rule, we can rewrite that as x squared squared minus 10x squared plus 9. Now, if we let u equal x squared, we can rewrite this equation as u squared minus 10u plus 9 equals 0. Okay, if we look at the second row, now we have fractions. So we have 5x to the 2/3 power plus 11x to the 1/3 power plus 2 equals 0. Again, we can rewrite it so that this first term has 5x to the 1/3 power squared plus 11x to the 1/3 plus 2. And then now, if we let u equal x to the 1/3 power, we can rewrite it as a quadratic, 5u squared plus 11u plus 2. Now, here's the thing to notice. Whatever we use to substitute is always going to be your middle term. Okay, so that's the easiest way to figure out what you're going to use for your substitution. Okay, so if we look at this first example, x to the fourth minus 8x squared minus 9 equals 0. Okay, so if we look at our middle term, we have x squared. So we're going to rewrite this, or we're going to let u equal x squared. If we do that, you want to go in a little bit further. If we square both of those, it tells us u squared equals x to the fourth, because our power rule says we multiply those exponents. Okay, so we can rewrite this equation as u squared minus 8u minus 9 equals 0. Now, since we have a quadratic, we can go ahead and either use quadratic formula or factor. Let's check to see if it factors. So if we do our a times c, we get -9. Our factors of -9 that add to be -8 are -9 and +1. And since our value for a was 1, we can factor this to be u minus 9 times u plus 1 equals 0. Okay. Now we're going to solve for u. So u minus 9 equals 0. U plus 1 equals 0. So u equals 9. And u equals -1. But here's the thing. We really don't care what u equals. We wanted to know what x equals. So now we're going to plug back in. Okay, so u is actually x squared. So we're going to plug x squared back in. So we get x squared equals 9, or x squared equals -1. And then we can solve using square roots. So we're going to square root both sides. So x equals, don't forget your plus or minus, and the square root of 9 is 3. Square root again. We have x squared, square root is x, equals plus or minus, and the square root of -1 is I. So there's your 4 answers. You can also list them out, -3, 3, -I, I. Either way is fine. Okay, so doing the same process, let's look at B. Okay, so we have 3x to the 2/3 power minus 11x to the 1/3 power minus 4. So again, figure out your middle term and let your u equal that. So u equals x to the 1/3 power. Let's go ahead and find what u squared would equal by squaring this. Remember, we multiply our exponents. So this becomes x to the 2/3 power, which is what we have in our first term. So we can rewrite this as a quadratic to be 3u squared minus 11u minus 4 equals 0. Okay, so if we want to factor, we have 3 times negative 4 equals negative 12. And our factors of negative 12 that equal negative 11 are negative 12 and 1. So replace our middle term with our two factors. And then factor by grouping. So 3u squared minus 12u. Our GCF is 3u. And we would be left with u minus 4. 1u minus 4. Our GCF is 1. And we're left with u minus 4. So our factored form, u minus 4 times 3u plus 1 equals 0. We want to solve for u, break it apart. U minus 4 equals 0. 3u plus 1 equals 0. And then simplify. U equals 4. 3u equals negative 1. So u equals negative 1/3. Okay, remember now we need to plug back in. So remember we had u equals x to the 1/3 power. So if we plug that back in, we have x to the 1/3 power equals 4. And x to the 1/3 power equals negative 1/3. To get rid of that 1/3 power, we're going to cube both sides. So x equals 4 cubed, which is 64. And then if we cube again, we get x equals a negative 1 cubed is 1, and 3 cubed is 27. And there's our two solutions. Okay, and looking at C, we have x squared minus 5 squared plus 3 times the quantity x squared minus 5 minus 10. So again, look at your middle term, everything other than the coefficient. So we're going to let u equal x squared minus 5, which tells us u squared equals x squared minus 5 squared. So if you wanted, you could go ahead and FOIL this first part, x squared minus 5 squared, and then solve it like we did example A, but you're just creating a lot more work for yourself, right? Because we can now rewrite this as simply u squared plus 3u minus 10 equals 0. So now if we factor, we have a times c gives us negative 10. And our factors of negative 10 that add to be 3 are 5 and negative 2. So this factors to be u plus 5 times u minus 2. If we break this apart, u plus 5 equals 0. U minus 2 equals 0. So u equals negative 5, and u equals positive 2. Okay, now remember we need to plug back in our u, so we can solve for x squared, or sorry, solve for x. So now we can rewrite this as x squared minus 5 equals negative 5, or x squared minus 5 equals 2. We want to add 5 to both sides. So x squared equals 0. Square root both sides. When we square root, we normally put plus or minus, but plus or minus 0 is still 0. And then x squared minus 5 equals 2. Add 5 to both sides. X squared equals 7. Square root both sides. And x equals plus or minus the square root of 7. We can't simplify the square root of 7, so that is our solution.